Okay, so we want to continue with our discussion of the Moon and Mercury. Another way that the Moon and Mercury are similar to one another is that they have no atmosphere. So the reason for that is because, air molecules move very, very fast because of their temperature. Now, we already mentioned that the Earth has a much higher escape velocity than Mercury and even higher still than the Moon. And so things that are moving at a sufficiently high speed are going to escape the gravity of the planet that they're bound to, or the Moon. So here's what happens with the atmosphere. If the molecules of air are moving fast enough, they'll literally escape from the planet. Now, when you have something like the Earth, there's basically a few different things coming to play. If the atmosphere is made up of lighter molecules, they're going to be moving fast. Lighter molecules will move faster and they're more likely to escape. We don't find hydrogen or helium in our atmosphere because those are the smallest atoms that are on the periodic table. And if you have any helium or any hydrogen in the air, it's going to move so fast that it'll eventually just leak out into outer space. It will work its way up to the top of the atmosphere and just dissipate. And so, if we have any hydrogen or helium, it's because we've extracted it from underneath the ground in the case of helium. Or in hydrogen, we can actually find chemical compounds that have hydrogen in them. Like we know H2O is water, two hydrogen and one oxygen. You can actually separate water into the separate constituents of hydrogen and oxygen. That's one way that you can get hydrogen. You can get it from many other different compounds as well. But the point is that if the Earth's atmosphere was just hydrogen and helium, it would have escaped long ago. Now, heavier molecules move slower, and the Earth's gravity is strong enough to hold them in. That's why our atmosphere is with oxygen and carbon dioxide and nitrogen and these heavier elements and compounds are able to be retained by the Earth. But Mercury and the Moon, they're much smaller and their gravity is much weaker. And so any atmosphere that they might have is just going to leak out into outer space. So, a few interesting facts about our exploration of the moon. The first spacecraft to ever fly past the moon was in January of 1959. The first spacecraft to crash land on the moon was in September of 1959. And by the way, that crash landing on the moon, that was on purpose that it crashed. The first pictures of the far side of the moon. In the previous presentation, I showed you a picture of the far side of the moon. The first pictures, the first time any human beings ever saw what the opposite side of the moon looked like was way back in 1959. And so far, the United States is the only country to actually send people to set foot on the moon. The first person on the moon happened in July of 1969. That was Neil Armstrong, and then also Buzz Aldrin, who was also in the lunar lander with him. And then the last person to set foot on the moon happened in 1972. Now, we can see the surface of the moon is cratered. That's because of impacts from other celestial bodies like meteoroids. And so they come down, they strike the moon, and that basically leaves an impact crater. Now, craters are typically about 10 times as wide as the meteoroid that created them, and they're about twice as deep. And when the meteoroid strikes, it hits the ground, the rock of the ground is basically pulverized. Much of the surface of the moon is covered in this sort of sand-like material called regolith because these impacts have just like busted up the surface of the moon. Now, a lot of the craters that we see on the moon are very, very old. On the Earth, if something strikes the Earth and leaves an impact crater, very often what happens is that crater gets covered up or it gets eroded away because the Earth is geologically active. We've talked about continental drift, we've talked about erosion, the wind. All these things happen to like reshape the surface of the Earth because the Earth is geologically active and the Earth has weather. On the moon is not geologically active. It doesn't have volcanoes anymore. It doesn't have things that would change its surface features, and it doesn't have weather. It doesn't have any atmosphere, any wind to erode away the surface. And so some of the craters that we see are very, very old. How old? Some of them actually date to 3.9 billion with a B years ago. That was a period in the early solar system when there were a lot of things smashing into the different planets and leaving craters behind. Now, the Earth was once covered in craters just like the moon, but because of the geological activity and the weather, those craters have mostly been erased. Now, craters, as I said previously, they come in all sizes, from the very large to the very small. And you can see here are some examples of some very small craters. That's just sort of the main surface feature that we see on the moon is all these craters from these different things that have struck the moon. Now, another thing that's interesting, the Earth's atmosphere is another reason why the Earth is not continually being bombarded with things like the moon. When small things strike into the Earth, they pass through the atmosphere, and the friction as they pass through the atmosphere, because these things are moving very, very fast, the friction heats them up so hot that they tend to shatter and explode and melt, and basically they don't even make it to the surface. But the moon doesn't have any atmosphere to protect it like the Earth does. And so even very, very tiny things coming in from outer space that strike the moon, there's nothing to erode them away, nothing to vaporize them. So the moon is going to be hit by all manner of things from large to small, and the little tiny ones even can make these tiny little impact craters. Now, the surface of the moon, as I said, is it's covered in this dusty, sandy-like material called regolith, and this regolith is this layer of dust that's left by meteorite impacts. Even today, the moon is still being bombarded, especially by very small micrometeoroids. That was actually a concern for the astronauts that, they would be out on the surface of the moon and something might rain down on them and damage their spacesuit. But fortunately, that didn't happen. Now, while most of the impact features on the Earth have been eroded away with time, there are a few that were large enough to endure. This is Meteor Crater, which is in Arizona. It's a famous, very large crater. You can see here, it says access road. You can see this little tiny road. That's how you get there. And so that just gives you a sense of the scale for just how big this crater is. And if you ever find yourself standing on a corner in Winslow, Arizona, Meteor Crater is only about 20 miles away from you. So if you ever visit Arizona, it's something to see. It actually happened, the impact happened about 50,000 years ago, and it was created by a meteorite that was about 160 feet across. And nobody really knows exactly how fast it was going, but basically it was going tens of thousands of miles per hour, 20, 30, 40,000 miles per hour, something like that. And now it is a pretty popular tourist attraction, so maybe something that would be really cool to see someday if you've never had the chance. Now, I mentioned that the moon is not geologically active anymore, but it was at one time. The moon was, it had lava in its interior, it had volcanoes, and these volcanoes would create eruptions. You would also have geological activity. That's why the moon has these mountain ranges. And it also has these things called rills, which are basically like channels. So you can see here is the Hadley Rill, which is like a, almost think of it like a canyon. It's just a channel. And here are the Apennine Mountains. This is another place where later, we all know about Apollo 11, Neil Armstrong landing on the surface of the moon. Some of the later Apollo missions landed in this area, and they explored Hadley Rill and the Apennine Mountains, and it provided some very breathtaking pictures of the surface of the moon. Now, if we turn our attention back to Mercury, it's actually less heavily cratered than the moon, and it has some very distinctive features, such as scarp, which is several hundred kilometers long. It's like basically cliffs, and up to 3 kilometers high. Now, the two main surface features of Mercury are the Caloris Basin, which is a very, very huge impact crater, much bigger than Meteor Crater in Arizona. I mean, this thing is gigantic. And on the opposite side of the planet is this region called, and this is what it's really called, the Weird Terrain. So here's what happened, and we don't know exactly when this happened, but there was this large object that struck the surface of Mercury, and this is called the Caloris impact, and this is where the Caloris Basin would happen. And this impact was so large, it sent shock waves through the planet. And so some of the shock waves went straight through, some of them went along basically traveled along the surface. And so you can imagine the waves traveling along this surface and the waves traveling along the opposite surface. They would kind of come together on the opposite side of the planet and release energy there. And that caused basically this side of the planet, these combining seismic waves would create upheaval. Seismic waves we think of them on Earth as being earthquakes. Well, this would be like a giant Mercury quake. And this created upheaval on the opposite side of Mercury. And the terrain there, it just is at very weird angles. It doesn't look like a natural phenomenon, even though it really is. And so it just came from this impact. Now, considering the moon again, if we look at the moon's density, I already pointed out that the moon's density was really low. And another thing that's a feature of the moon is that it does not have a magnetic field. And so these things together, the fact that it has such a low density, suggests that it does not have a lot of iron or nickel. And in fact, its core, unlike the Earth has an iron-nickel core. The moon does not have that. And that's important because it helps us understand how the moon originated, which for a very, very long time was an open question in astronomy. In fact, the moon's origin wasn't actually really determined until the 1980s. People had a lot of different theories about how the moon came to be, but finding out, exactly how our moon formed was something that was, it took a long time. And the fact that the moon's core is not made out of iron and nickel, that was a big clue. Now, Mercury, on the other hand, is much denser than the moon. As we saw previously, it has a comparable density to the Earth, and it has a very weak magnetic field. This field is probably due to a molten core similar to the Earth's. But, Mercury is very, very far away, and we haven't sent a lot of things there to really investigate it. So we're not really sure exactly what's going on there. And as we saw previously, the rotation rate of Mercury is very, very slow. And so that also contributes to its very weak magnetic field. If it was rotating faster, you might expect to see a larger magnetic field. So how did our moon come to be? This is a big question, and people had proposed a lot of different theories about how the moon had formed. Some people thought that the moon was basically a piece of the earth, that when the earth was forming, it was spinning around, and just a big chunk of the earth just kind of flew off and became our moon. Other people proposed that maybe the moon was like a rogue planet that just kind of happened to pass by the earth and get caught by the earth's gravity. These were some theories that people investigated, but it turns out that those are not actually possible. Um, it was shown that the moon could not have originated from the earth. It couldn't have been like a piece that spun off. And it actually couldn't be just like a rogue planet caught by the earth's gravity. The earth's gravity, it turns out, is not strong enough to do that. And so how did the moon come to be? And the current theory is basically this. Very early in the Earth's history, before the Earth had even become fully solidified and it cooled down into a solid, the Earth was just hanging out. And so here we have the Earth. A planet, another planet, happened to come and strike the Earth with sort of a glancing blow. And that impact was so strong, it basically ripped that planet into shreds. Now, this was a planet about the size of Mars, so something roughly about the third of the size of the Earth. And it shattered into this big debris field. Now, this impact basically melted the entire Earth. And the denser elements, things like iron and nickel, they tended to fall down into the core. If you have a liquid that has a different density, a heavier density, it's going to tend to sink. And so this impact basically created such heat that it completely melted the Earth, and the Earth was already not even fully solidified. So all of the iron and nickel tended to float down into the center and form the Earth's core. Well, this combination, this image that you can see here, is a computer simulation. So you can see sort of the impact, and this is the Mars-sized body striking the Earth. And the Mars-sized body just basically shatters into this debris field, and you can see that the heavier, denser things shown in the blue, they basically kind of got absorbed, and what you're left with was this sort of debris field. And over time, that debris field was attracted to itself by gravity, and it reformed together into the Earth's moon. And so the Earth's moon is actually the leftover remnant. So part of that planet that crashed into the Earth got sort of absorbed by the Earth. The leftovers kind of spun off into outer space, and over time, all these particles and dusts and rocks, they were attracted together by gravity, and they formed into our moon. This is called the giant impact theory, and this is a currently accepted theory for how our moon came to be. So hopefully that's interesting, and we'll come back and look at some of the other planets in the next videos.